All right, welcome back to Talk Tensors. We know you're all busy keeping up with the absolute latest and greatest in machine learning. So are we, and that's why we do these deep dives.
Today, we're looking at a paper all about, well, I guess you could say it's about speed. Like, how do you get an AI to make split-second decisions, especially when you've got a really complex environment?
Yeah, visually rich, lots going on. Think like a video game.
Yeah.
Like, those action RPGs where you got to think on your feet?
Exactly, yeah. And this is where the paper comes in. It's about CombatVLA, a brand new vision language action model specifically built for that real-time combat in ARPGs.
And for those who haven't been glued to every gaming forum, the paper specifically uses Black Myth, Wukong, as an example.
Awesome game, by the way.
It is, and it's perfect for showcasing just how difficult this problem is.
Because it's not just about seeing what's happening, right? Like in Wukong, you have to understand the enemy's moves, the environment, your own abilities. You have to react instantly.
And make smart decisions, tactically. Can't just button mash your way through.
Exactly. And that's why this paper is so important. It's tackling a big challenge in AI. That gap between knowing what to do and actually doing it in real time.
Yeah, and it's exciting because even though they're using video games as a test bed, think about the real world application.
Oh, totally. Anything that requires quick thinking based on what you're seeing, self-driving cars, robots in like disaster zones, anything like that.
So they're not just presenting a new model here. It's a whole framework. It's how to collect the right data, how to evaluate these AI agents, how to train them effectively.
And it's a whole package deal. So maybe we should break it down a bit, starting with why existing VLAs struggle in these situations.
Yeah, good point. The paper starts by laying that out pretty clearly. Like, why isn't this problem solved already?
Well, think about it. Some existing approaches try to cheat a bit. They use APIs, so they're not really learning to see the game. They're just getting the info directly.
Right, like peeking behind the curtain.
Yeah, and then there's reinforcement learning. Works great in some cases, but you need a ton of training data, and figuring out the reward system can be a real headache.
Plus, it takes forever to train.
Then there's the large language models, the LLMs, super smart, great at reasoning, but way too slow for this kind of thing.
Can't be taking minutes to figure out what to do when that enemy is about to smash you.
Exactly.
Yeah.
So CombatVLA is their attempt to solve all this. And one of the first things they did was they built something called an action tracker.
Okay, so what's that about?
Well, it's all about gathering data, right? They needed a way to connect what a player is doing to what's happening on the screen.
Like what buttons they're pressing, what's happening in the game at that exact moment.
Exactly. So this action tracker records keyboard inputs, mouse movements, and it takes screenshots timed perfectly with all that.
Smart. It's like a super detailed game recording that says, at this moment, the player pressed this button, and this is what the game looked like.
Yeah, that's it. And that kind of data is gold for training a model like CombatVLA.
So they've got their data collection sorted. But how do they know if the AI is actually understanding what's happening in these combat situations?
That's where C-Bench comes in, the Combat Understanding Benchmark. This is a big deal because it gives researchers a standard way to test how well AI models understand combat.
Like, is it just reacting randomly, or is it actually making intelligent decisions based on what it sees?
Right, and C-Bench is based on, you guessed it, Black Myth, Wukong. They've got nearly 1,000 different test cases, all carefully crafted to test different levels of understanding.
So some are about understanding a single image, like where's the enemy, what's the environment like? Others are about understanding a sequence of images, like what happened, what's about to happen.
And get this, they actually use GPT-4o to help them create these test questions.
Right. Really?
Yeah. Of course, they had human experts double-check everything, but it's a pretty clever way to come up with a lot of different scenarios.
And it highlights how these different AI tools can be used together, right? Okay, so we've got the data, we've got the benchmark. How do they actually train CombatVLA?
So this is where things get really interesting. They've got this 3-stage process they call action of thought training.
Action of thought, what's that all about?
So it's based on the idea of chain of thought prompting, which you might have heard of. It's basically getting the AI to think step by step.
So instead of just saying, do this, you're making the AI explain why it's doing something.
Exactly. And that helps it learn to reason more effectively. So in the first stage, they're training on whole video clips, getting the AI to understand the overall flow of combat.
Then they zoom in. Right.
Yep, stage 2. Now it's all about individual frames, making those split-second decisions based on a single snapshot of the game.
Okay, and stage 3.
That's where they get really clever. They introduce this idea of truncated action of thought.
Truncated, so like cutting it short.
Exactly. They realized that during gameplay, you don't need the AI to explain its whole thought process. You just need the action.
Right, you just needed to act fast.
So they train it to cut off its explanation early, right after it figures out the action. This speeds things up a lot.
That's really smart. So they're optimizing for speed without sacrificing the reasoning ability.
Exactly. They also use this special token, it's like a marker, a TRUNC token, to signal where to cut the output short.
So all of this leads to CombatVLA itself. It's a 3 billion parameter model, which is actually pretty small compared to some of the giants out there.
Yeah, and that's important for real-time applications. You don't want a model that needs a supercomputer to run.
But size isn't everything, right? It's how you train it.
Exactly, and they use these adaptive action-weighted losses. It's a fancy way of saying they prioritize learning the most important actions.
So like dodging a fatal blow is more important than just moving slightly to the left, right?
Exactly. And they make sure the AI's visual understanding is really tightly connected to those crucial actions. Like it doesn't just see things, it understands what those things mean for its next move.
Okay, so we've got the model, it's trained, it's thinking fast. How do they actually get it to play the game?
They built this action execution framework. It's basically a bridge between the AI and the game.
So it's watching the game, feeding what it sees to CombatVLA, and then telling the game what actions to take.
Yeah, it uses a library called Putogui, which is actually pretty common for automating stuff on your computer. But in this case, it's controlling the game in real time.
And they even pause the game briefly while the AI is thinking.
Which is really cool because it shows they're serious about this real-time aspect.
Okay, so this all seems pretty impressive, but to really appreciate it, we should talk about the history of AI in gaming, right?
Definitely. It's been a long journey, starting with those really simple AIs in early games, the ones that just followed basic rules.
You know, like always walking into walls, that kind of thing.
Yeah, those were the good old days. Then came reinforcement learning, which was a huge leap forward. We saw AIs mastering incredibly complex games like Go and StarCraft.
And these were AIs that could learn and adapt, right? Not just follow pre-programmed rules.
Exactly. But more recently, there's been this growing interest in using large language models and vision language models for gaming.
Because the idea is to create AIs that can interact with games more like humans do, right? Not just be super efficient, but also be more creative and maybe even unpredictable.
Yeah, that's the goal. But real-time action games, the ARPGs we've been talking about, have been a real stumbling block.
They require such fast reactions and the visuals are so complex. It's a whole different beast than, say, a turn-based strategy game.
Right. Think about chess versus Black Myth, Wukong. In chess, you have time to think, to plan your moves. In Wukong, you need to react instantly.
And that's where those traditional large language models fall apart. They're great at reasoning, but they're too slow.
And while those reinforcement learning agents can be incredibly skilled, they often need a ton of training specifically within that game. And they might not adapt well to new situations or changes in the game.
CombatVLA is trying to bridge that gap.
Yeah.
It's using a relatively small model, it's trained on data that's directly linked to player actions, and it's all optimized for speed.
And like you mentioned earlier, the creation of C-Bench is huge for this field of research. It gives everyone a common standard for measuring how well an AI understands combat.
It's like having a ruler for AI combat intelligence. Okay, so we've covered a lot of ground. Let's break down some key takeaways for our listeners.
All right, so first off, CombatVLA achieves state-of-the-art performance in understanding combat scenarios.
Yeah.
And it does this with a model that's only 3 billion parameters.
That's pretty small compared to some other models out there which can have hundreds of billions of parameters.
And that efficiency is crucial for anything that needs to run in real time.
Takeaway number 2 is that the action of thought format seems to be key to enabling that reasoning ability.
It's like forcing the AI to articulate its thought process before it acts, which leads to more informed decisions.
And the progressive learning strategy seems to be working really well. They start with a broad understanding of combat and gradually refine it to the level of individual frames and then those truncated outputs.
And that final stage, the truncated action of thought, is super important for achieving those real-time speeds.
We also need to emphasize the value of the action tracker and CU bench.
Yeah.
Those are real contributions to the research community.
Totally agree. Having those tools is going to accelerate research in this area.
Another takeaway is that CombatVLA seems to generalize pretty well. It performs well on new tasks within Black Myth Wukong, and they even show some promising results in Sekiro, Shadows Die Twice, which is a completely different game.
And get this, in some cases, CombatVLA actually outperformed experienced human players.
That's pretty wild. It shows just how powerful these models can be. Okay, so we've talked about what the paper achieved. Now for the fun part, our novel notions segment, what are some exciting directions for future research that build on this work?
Ooh, good question. One thing that comes to mind is incorporating a memory module into CombatVLA.
So right now, it's just reacting to what it sees at that moment. But with a memory module, it could start to learn from past interactions.
Exactly. Imagine CombatVLA facing a boss with a complex attack pattern. With a memory module, it could start to predict what that boss is going to do next based on what it's done in the past.
That would make for some seriously challenging AI opponents.
It would. And it could draw on research in recurrent neural networks or transformer-based memory architectures. There's a lot of potential there.
Okay, what else?
Another interesting direction would be to use adversarial learning to make CombatVLA even more robust.
So instead of just training it on data from human players, you'd also train it against an AI that's specifically trying to exploit its weaknesses.
Exactly. You'd create these really challenging scenarios that force CombatVLA to adapt and improve.
And that would make it more resilient to unexpected situations like new enemy types or changes in the game.
Right. This approach has worked really well in other areas of AI, like image recognition, and it could be really valuable here too.
Those are some really cool ideas. It's exciting to think about where this research could go.
Absolutely. CombatVLA is a great foundation for future advancements in intelligent AI agents for complex environments.
And for anyone who wants to dive deeper, we highly recommend checking out the open source resources linked in the description. They've got the data set, the benchmark, and even the model code.
You can really get your hands dirty and see how it all works.
So as you ponder all of this, we'll leave you with this thought. How could similar models that combine visual understanding and fast action revolutionize other fields beyond gaming?
What about robotics, self-driving cars, even medical diagnosis? There's a lot to think about.
Lots of potential for sure. So that wraps up our deep dive into CombatVLA.
This has been Talk Tensors.
We'll be back next time with another exciting piece of machine learning research. Until then, keep learning.